Good morning, fancy meat computers. How are you? How is it? How is it going? Hopefully everybody is having a wonderful, wonderful Tuesday. We are going to finish this topic today or die trying. Or try dying. We've only got 12 people watching at the moment. 13, okay. You guys have a midterm today as well? Or is it the same midterm? You're just studying for it 2 days in a row, skipping all your classes to do so. Oh, 19. Okay, we're getting there. Oh, I posted this as an announcement, but I might as well mention it. Salutations and greetings, friend. Felicitations and salutations. So last time during the stream, I posted the midterm room. The time indicated is 8 p.m. to 10 p.m. I would just like to clarify that that's just when we have the room booked, right? That's not meant to indicate the duration of the test. The duration of the test is 1.5 hours or 90 minutes. It's not a 2-hour test. You should be out of there by 9:30. There's like 15 people in HH302. Do they have the projector code? Awesome. Oh, okay, all right. Oh, okay, all right, that makes sense. I never considered that people who are watching on the projector don't occur on the view count. All right, that makes sense. Well, thank you for letting me know. I feel less bad. Hello, all you people. This. Wait. Okay, let me see. The podium is this way, right? Yeah. There's an 8% test tomorrow in a class most of us find difficult. Ah, but it's only 8%. My test is worth way more than that. 8%, that's like... That's nothing, man. 8%. You could still get... You can not even submit it and still get an A+. Anyway, so... Let's talk about dynamic memory allocation. Hi, would the string for question 1 be... I really seriously need to get through this material, so if you could hold questions for the hold questions about the assignments for Piazza or some other thing, that would be good. We have to get moving on this material because we are seriously behind. So, dynamic allocation, in its essence, we're performing the same action that allows us to declare static arrays, but we're doing so dynamically at runtime rather than having to know the value of the array up front, right? So with static arrays, right, the size of the static array, like, first, it needs to be calculatable, right? It needs to be there when the array is created, and it can't. The array can't be resized once created, right? Not to mention, the array is also stored in, like, static arrays are stored in the stack, in the system call stack, right? So when the function that creates the array is deallocated, the array is also deallocated. One other feature of dynamic memory allocation is that when the operating system gives you memory, it's not giving you memory inside the system call stack. It's giving you memory inside of the heap memory, which is a different memory model that's distinct and different from stack memory. It functions. It's like the same place that that external variables are stored. So, dynamic memory allocation basically is a bunch of operations that produce pointers to the memory that you're being allocated, right? We already talked about malloc, but very briefly, you put the size of the thing, the size of the memory you want to set aside in bytes in, you get a pointer to that memory out, you have to cast it as the type of memory that you want to interpret it as. Because malloc doesn't know or care what the data type is for the memory it's giving you, it just gives you X number of bytes. If malloc fails, you get a null pointer. So whenever you use a malloc operation, it is the rule of personal sanitation that you must always check to see that the pointer is non-null before using it or dereferencing it, because dereferencing a null pointer is a seg fault, and it's your fault too. It's not seg's fault, it's your fault. Terrible joke. Terrible joke. So if you want that in like slightly more, if you want that in green, in a green block, here's how it goes. So int pointer cast as int pointer malloc 5 times size of integer allocates a pointer to 20 bytes in memory. A large 20 byte memory block is dynamically allocated to pointer. So let's talk about free. We now know how to allocate memory, so let's talk about how to deallocate memory. Memory manually allocated using malloc must be deallocated manually as well. More advanced programming languages have subroutines called, variously things like garbage collection, right? Java, for example, has garbage collection. It will go up and collect all of your dead references and recycle them for you. It does this periodically. C does not support garbage collection. If you lose the reference to the memory you've allocated, that memory just stays allocated forever and ever until your system reboots. This is actually this is a huge problem in Windows operating systems because Windows was programmed by syphilitic gibbons. Windows has a big problem with what's called memory leaks. This is what the term memory leak means, if you've heard the term before. When a program does not deallocate all of the memory that it allocates to itself, that dead memory accumulates inside of the system's RAM, right? You just have increasingly large regions of memory spotting the RAM that are not used by anybody, but were never dereferenced properly, so they're still not used right? But they're just hanging out there and blocking that memory from being used by other processes. So the memory is leaking. It's losing value over time. It's like a boat that's letting water in, right? And it's just filling up over time. This is why, with respect to, like, with Windows machines, you have to restart them, like, every couple of days or however long, right? Otherwise, they start getting really, really slow, right? And you'll notice there's, like, one limit where the system, like, really starts to get slow if it's been on for, like, exactly 3.5 days or something like that. And the reason for that is that the memory leaks have accumulated and accumulated and accumulated to the point where your system no longer has enough RAM to do what it needs to do with either your user programs or, like, even the operating system itself doesn't have enough RAM, right? So it starts using your hard drive as spare RAM capacity, which can be very damaging if you have a solid-state drive because they have a limited number of write cycles. So it's using your hard drive as excess working memory, like it's needing to pull into your hard drive and use it as working memory. The hard drive is much, 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 much slower, right? So that's why your whole system slows down, because it's caching to your hard drive. And that's why that's reason 3726 why Windows sucks. If you're a competent programmer and you just free the memory that you've allocated, then you don't have to worry about memory leaks, right? It doesn't matter. But freeing memory that you allocate is not something that will likely show up for like your user programs. It's not likely to like the programs you write in this class, it's not likely, you're not going to see any difference. But like when that problem exists inside of an operating system, it's extremely bad. If we have VS Code running, for example, when we close it, would all the memory used to store variables that we used in the code by free would it free your variables? So no, if you're running C, right, nothing gets freed automatically. Like, this is kind of the whole point of, like, this slide and everything I've set up to now. In some languages, you get away with it. Languages with garbage collecting will take care of it for you. C is not a language that has garbage collection, so no, you don't get VS Code isn't that smart either. And you also need to understand that the C program that you write inside of VS Code is not like in continuous execution on VS Code. It runs it once, it shows you the output. It doesn't just, keep running. Like, it's not like it's continuously open. It needs to reload and recompile the program when it runs it, right? Which is, again, why, I'm not a huge fan of VS Code. I think that if you really want to learn how C actually works, you would use the Pascal server. Honestly, you should always be skeptical of an IDE that tries to do too much for you, because it's training you into bad ways of thinking and bad habits. And that's what VS Code does. It trains you into bad habits. I always say that Unix is the original C IDE. Linux, in that sense as well, is like the Linux operating system itself is a C IDE. But anyway, so to deallocate is to take memory allocated to a program and return control of that memory to the operating system. If no program deallocated the memory it used, you would have to restart your computer very frequently. The free function accepts a pointer as an argument and deallocates the memory pointed to. While it is not enforced by the compiler, freeing dynamic memory is the same as closing file streams. Very good practice. So when we call free on a declared piece of memory, it just puts it in the bin. That region of memory is now available once again for the operating system to give to someone else. Here is an example. Do I have the output here? No? Okay. Dynamic.c, is this it? We'll save that for the end. Wait, is this malloc demo? Yeah, it's just like a slightly expanded version of it. So we take an integer n, we allocate a integer pointer with n elements in it. If that pointer is equal to null, we printf runtime error and return. We then print the memory is located at the pointer. We then set each element of the pointer, each element of that memory to an increasing index. The array is located in the allocated array is, and then it prints the array. That's a separate function. And then we free the pointer and return. So, very good. Let's see how this works. GCC, dynamic.c, boom, a.out. So, the location in memory allocated is thus. You'll notice, I hope, that like as we've been using pointers up to now, we've been having like FF here and then the rest here, right? But now we're starting with 5, 6. The reason that we're that far departed from the memory that we were using before is because that's the magnitude of difference in the memory system between stack memory and heap memory. This is heap memory, right? That's why these numbers are different. Question. If you free the space, would you be able to restore the pointer from the garbage into the space, or would it be irreversible? Freeing a pointer is irreversible. Well, yeah, it's irreversible because accessing memory that doesn't belong to you is a seg fault. Even if you keep the value of the pointer and try to dereference it later after you've freed, I imagine what would happen is the operating system would slap your wrist and say, no, you gave me that back, you can't have it. If you allocated enough memory for a 5-element array, can you use that memory to create a 2-element array, for example? Yes. Would it just create a 2-element array, or would it still be 5 elements with the rest being filled with garbage data? That second one. It would be... Basically, it's... What you're designating by using malloc and related functions is a sort of safe zone in memory. You are reserving that memory for yourself, right? You can use as much of or as little of the reserved memory as you like, though it's not good, from a practice standpoint to reserve much more memory than you need, right? But yeah, once that, with malloc, the memory is not wiped first. It's just given to you, so it's natively filled with garbage. So if you want to overwrite it with non-garbage data, then you do that, right? But yeah, if you want to use it for only 2 values and allocate 5, that's completely up to you. Wasn't the pointer... Okay, good. Wasn't the pointer you made void? How did the code know how much to increment when indexing? Oh, I'm missing the cast, aren't I? Oh, it must be... Well, the information is attached here, right? Oh, I know. Probably I would get a warning in... That's not an error so much as a warning. Let's see here. Let's see... W all. Am I getting a warning? No? Interesting. Strange. Strange and interesting. All right. So it's saying that the cast isn't necessary because it knows where it's going because it's already in a... it's already being put in a thing with the correct data type. So I guess there you go. You should still cast, though. It's good practice. All right. Right. So let's talk about C-alloc. C-alloc is M-alloc for the hygiene obsessed. C-alloc is almost precisely the same as M-alloc. The difference being C-alloc wipes the data before it gives it to you, right? So it accepts two arguments. The first is the number of chunks of contiguous memory to allocate, so the number of numbers. The second is the size of the chunks, so size of float, size of int, size of double, etc. So size and so number of bytes and number of chunks of these bytes to allocate are separate arguments in C-alloc. C-alloc wipes all allocated memory, i.e. it writes 0 to each chunk. Aside from this, usage is exactly the same as M-alloc. C-alloc is much slower than M-alloc, however, as overwriting the allocated memory takes time. M-alloc is a constant time operation, which means no matter how big the chunk of memory you're allocating is, it will always do so in the same amount of time. C-alloc requires like one operation per element that you're allocating in order to write 0 to it. So it's what we call a linear time algorithm. It takes an amount of time proportional to the size of the memory you're allocating, right? So it's much slower. But if you were going to overwrite everything with zeros anyways, then you might as well just use C-alloc. In what cases would void functions be used if they don't return anything? Well, you could use void functions if, well, there's a number of use cases. If the output that you're outputting is being, like, if you're more concerned with standard input and output, and you're not necessarily interested in the direct arguments and return values, then that's one use case. Sometimes you just, like, for example, my, in this guy, print array, all he's doing is printing an array. He doesn't have to return anything, right? So he doesn't. That's, you know, I've even left out the return statement, right? These guys, like, they just aren't concerned with passing anything back up the chain, so they're void. Could I do int pointer C-alloc int n equals 100 size? No, don't initialize variables inside of... Don't ever initialize a variable inside of a expression. Variable initializations get their own lines of code. Yeah, I'm not sure that would even work syntactically. Like, if you were going to do that, you might as well just write 100, right? Like, here's the question, right? With that particular one. What is the return value of a variable allocation operation? Because that's what you're passing into C-alloc. It's not necessarily going to be n or a reference to n. It might be some status code about whether the allocation operation was performed correctly, which is normally lost because you're not assigning it to anything because it's on its own line, right? Make sense? Good. So, calloc, enough said. So, realloc. Realloc is like, between realloc and malloc, that's pretty much, and free, those are the three that are like of primary importance. So, what if we need to dynamically change memory that's been dynamically allocated? Realloc allows us to change the amount of memory allocated to a pointer while keeping the data already inside of it. So, let's imagine we have allocated some region of memory, 40 floats, give that to pointer. Let's say, oh no, we need to add 60 more floats. How do we do this? Realloc, pointer, and then the new size. So for realloc, the first argument is the pointer you want to resize. The second argument is the new size, following malloc rules. Notice that you still need the assignment here. Realloc returns a pointer to the newly allocated memory. New chunks of memory will be filled with smelly garbage. So realloc is smart enough to try to put your new memory chunk in the same place as the old memory chunk, just longer or shorter. So this is not a problem with shortening. You can always shorten in place, but you might not be able to expand in place, right? If while expanding, or while selecting a region of memory to expand into, there's a conflict with some other pre-existing variable or array or something like that, right? You can't necessarily just, the value of the pointer here might change, right? Because you might have to move that pointer to a different region of memory that can accommodate the larger memory chunk, right? So, if that happens, what realloc does is it copies each element of the old array into the new larger array, and then it deallocates the old array, and it returns the pointer to the new array back to your program. So you don't have to worry about it freeing the memory, it'll do that itself. But yeah, at worst, reallocation is also a linear algorithm, because it might have to copy all these elements from the old array into the new one, or the old memory into the new memory. So there we go. So if we've malloced 5 integers, we have 20 bytes, and then we realloc this pointer to be 10 times the size of integer and assign that to pointer, pointer will be allocated 40 bytes of memory. Sound good? So, here's our realloc demo, which I might as well just run. So we are declaring pointer 5 integers. If it's null, runtime error. We are populating those values with 2 times whatever the index is. Before we print the array before reallocation, then we print the array after reallocation, and let's see what we get. There we go. So before reallocation, we get 02348. Wait, 02468, pardon me. And after reallocation, you can see the memory address has changed. This is a different memory address. It's very similar, but it's a different memory address. So these values have had to be copied into new memory. And we can, we can play with this a little bit. Let's say we're allocating 20, and we're resizing it down to 10. Let's see how that works. You'll notice that when sizing it down, we have retained the same memory address. So this did not require us to copy all of these elements into new memory, right? Does realloc point to the first element of the newly added on memory, or is it the pointer pointing to the very beginning of the whole chunk of memory? Very good question. In the same way that malloc and every array points to the first element of that chunk of memory, realloc's pointer also points to the first chunk of that memory, right? The first address in that memory chunk. So it does exactly the same thing as malloc, right? Make sense? Hopefully. There we go. And here's the output. There we go. So ends pointers. Any questions? Oh. Why isn't calloc cast? The same reason we got away with wow. It's size of int float, but it's going to an int. That's terrible. Should be returning a void pointer. Yeah. calloc is returning a void pointer, so the void pointer is being cast to whatever the data type of the variable it's being assigned to is. But if you weren't doing, like, it's still good practice to cast it explicitly. Let's see here. If we have been running malloc without freeing the memory between runs, is there a way to go back and free all of that memory? Would restarting the computer do that for you? There's no way to do that aside from restarting the computer. In order to free the memory, you have to have essentially you have to have a variable that knows the memory address. You have to know the memory address that you're freeing, right? Once the program, like if that pointer is being stored in stack memory or any other type of memory, for instance, once that reference to that memory has been lost, you lack the input to be able to free, and so you can't free it anymore. The only way is to turn the computer off and start it back up again. Does realloc always overwrite new memory with 0 like calloc, or is it just a coincidence that the new memory chunks were stored in 0? I believe that's a coincidence, but we can do a big example and see if we can do a big example and see if that still works. So calloc, let's say 10, 10, and let's say reallocating 1000. Let's do this. Oh, okay, so it must be overwriting with zeros then, because that's way too much. That's way we would be seeing some random garbage here, so it must be overwriting with zeros. There you go. So that makes it a linear time algorithm. There we go. Done. Done and dusted. Answer questioned. So, good. So much for pointers. Now let's talk about strings and file I/O. There we go. I'm going to try to zip through the unimportant parts here quite quickly, so hold on to your butts. This is going to be something about C programming. So, strings formatting and file I/O. Recall. In C, strings are encoded as character arrays, which are null terminated. In the above declaration, foo will be written into memory as BAR with a null character. Right there. Remember, all strings are arrays of characters which have a bit width of 1 byte. Strings are delimited with double quotes, and characters are delimited with single quotes. Many useful operations on characters are stored in ctype.h, one of C's standard libraries, one of the venerable standard libraries. Each function receives an unsigned character, represented as an integer, or an end-of-file command as an argument. EOF means end of file and is typically used to indicate the end of a file in your file system. While this is somewhat dependent on your operating system, EOF typically has a memory value of -1. Character predicates. A predicate is a term in mathematical logic, meaning a function returning a Boolean value. The functions below return true for indicated valid characters and false otherwise. So we have isBlank, operates on spaces and tabs. IsDigit on digits, alpha on alphabetic characters. IsAlNum works on alphanumerics, which is both of the previous two. IsXDigit is hexadecimal digit, so 0 through 9 plus A through F in upper and lower cases. IsUpper, IsLower, should be fairly obvious. These are very useful if you're writing a program that needs to know something about the characters that it's operating on. So blank is somewhat different from space. Space includes things like new line, vertical tab, feed, and carriage return. That's what all these guys are. Is control characters. So, you know, some of those characters at the beginning of the ASCII code that we didn't talk about really. Punctuation, printed characters other than alphanumerics and spaces. So everything that's not everything that's non-alphanumeric and is not a space is a punctuation according to a computer, including things like ampersand, percent sign, plus sign, minus sign, equal sign, tilde. All these are punctuation, even if they're not like properly English punctuation marks, or in any language really. Like math symbols are technically punctuation under this definition. IsPrint are printed characters, those characters that actually are displayed. That's most of them. Things like null are not printed characters. IsGraph targets characters which are not printed. Any character which is printed to your monitor is a printed character. The null character is a good example of a non-printed or graph character. You can always test for a specific character using double equals. The C-type standard library includes two functions which transform characters from one form into another. ToLower accepts a character and returns the lowercase version. ToUpper accepts a character and returns the uppercase version. In both cases, if the corresponding upper or lowercase character does not exist, then the character is returned unchanged. So, for example, if you wanted to decapitalize every word in a sentence, you could just run ToLower on each character in the sentence. You don't have to test them to see if they're capitals first and then to lower them. Because if it's not lowerable, then it'll just return it as is. Cool. Any questions about characters and character transformers? Give me a thumbs up. Smash that like button. Just destroy it. Okay. I have not... Oh, there we go. We received 1 thumbs up, 2 thumbs up. Excellent. Latency is kind of long. Oh, well. Oh, all right. Cool. I didn't quite get how the characters become integers. So they're still stored as character codes. It's just, like, that's mainly for back compatibility. If you were to cast these as chars, then everything would be fine. Early versions of C probably didn't have a character type, and these functions need to maintain back compatibility with like that's the thing about C is like every C program that has ever been written for C is still a valid C program. So you know, so that's probably the reason. But just pretend they're characters and everything will still work. The concept of data types is somewhat ephemeral. So, this doesn't really have to do with characters, but it's about time we talked about the ternary operator, because this operator is coming up in a few examples, and I don't want you to be overly confused. If statements are great, but somewhat clunky. There must be a better way. So imagine you have an if statement of the following form. We have if b x equals y, else x equals z. Do the predicates only look at a single character, or can it work on an array? No, it's only a single character operation. If you want to run it over an entire array, you have to put it in the loop, my friend. And if it can work on an array, how would the output look? Again, you have to do that manually, using a loop yourself. So, if you're making an assignment and you're like assigning 2 different things in the 2 cases of an if statement, one way you can do that is using the ternary operator. So you put your condition, the question mark character, the true case, colon, the false case. And this expression will return y if b is true, or if b turns out true, and z if b comes out false, and then when coupled with the assignment operation, assigns those to x. So this is like an in-place if statement. Ternary is a trinary operator. B is a Boolean expression, such as a condition. Y is an expression and is the result if B is true. Z is an expression and the result if B is false. The ternary operator is an expression, not a statement, so they may be used in place of an expression. So may be used in any place an expression is allowable. So, for example, you can use them during variable declarations. You can use them inside of indexing statements, or inside of indexings. You can use them inside of print statements, although there should be a format tag here somewhere. If you are the type of person who obsesses over minimizing your lines of code, then this is the operator for you. Ternary is not faster on modern compilers, although at one point it was. Whether or not they improve readability seems to be a matter of taste. Some people think that ternary operators improve the readability of code, others do not. And, you know, it's a matter of personal preference, really. So, now we're going to talk about some conversions. The null character has a very important function in C. You may have noticed that C does not know when an array ends, though it always knows where one begins. The null character is used to indicate the end of a string in all standard library functions. Using the fact of null termination in your own code is also a very good idea. A common pitfall is not allocating enough space in your character array for the null character. If a string is missing its null character, the functions in the standard library will continue operating into memory space not allocated to the character array. This will introduce at best, smelly garbage into your program, and at worst, a seg fault. But again, it's not seg's fault, it's your fault. The C standard library, stdlib.h, defines str2d, string to double conversion, which converts decimal numbers into double precision floating point numbers, or doubles. So, this is what we're going to look like for a while. Is like, here's a function definition, here's a function definition, here's a function definition, here's a function definition. So, here's how it works. Constant character array string and character double pointer end pointer. str is a pointer to the string to be converted. Leading white space will be ignored. str2d converts as much of the string as it can to a double, and then returns that double. The return value is the double that it read. End pointer is the address where str2d stores the address of the character that it stopped on. So basically, you give it a memory address, and into that memory address it puts a pointer to the original array, pointing to the character it stopped on. Right? Do integer arrays also end in null? No. Integer arrays do not end in null because 0 is considered a valid value. Right? It is necessary to be able to put 0 in an array, therefore we cannot reserve it as a special value that we use for an operational basis like we do with strings. So because characters encode lots of different things, one of those character codes can be used for these purposes, and that happens to be the null character 0. We could have just as easily chosen, some other unused character code. But yeah, no, 0 is valid as valid for integer arrays, so integer arrays simply do not know what their last element is, and it can be anything. So, good. End pointer is the address where str2d stores the address of the character it stopped on. Yes, this is an example of a function using pointers to, in effect, return two values. So this is what we call pass by reference and implicit return value. So the explicit return value is the double that we are returning from the character conversion function. The implicit return value is the character that we stopped on, the first character in the string that was not a valid part of the number we are converting. So there. For example, constant char string is 51.2% are admitted. String pointer is we create a character pointer. This is going to be the pointer to the end of the convertible section. Double D is equal to string to D string pointer, address of string pointer, I should say. Then we print the string and convert it, and we print what its conversion value is. And then we can also, which is interesting, print the rest of the string. Right? Because a pointer to a string functions as a string. You can actually print it using the string format tag. So the string 52% are admitted is converted to the double value 51.2, and the string % are admitted. So this guy, if read as a string, will do just what strings do, which is read out characters until they hit a null value. Boom. All right. Any questions about that? If we had letters in front of 51.2% in the original string, what would happen? It would fail to convert. It would fail to convert anything. Leading white space is fine. but it needs it can't have letters. Like basically it assumes that the first chunk of the string you're converting is either blank space or a number. So basically what you do is you write an algorithm that, has a pointer scan through the string until it hits its first numeric character, return that pointer to string to D, right? And then that'll give you your number back. Make sense? So would that produce an error or just assign that full string to the address of string pointer? Likely that second one. I don't know what the return result would be. Let me look up string to D in the standard library documentation. Okay. This is not a lot of information. No, this is also not a lot of information. Ah, there you go. If no valid conversion could be performed, the function returns 0. 0.0. So in the case of failure, it returns 0, which is not ideal, of course, because 0 is also in the range of things that could be valid return results. But, I guess we're making a compromise here on that point. Why did you use address of string pointer? Why not dereferenced or double dereferenced string pointer? Well, let's consider it this way. As defined in the standard library, end pointer is defined as a double character pointer, right? As usage, we want a pointer, like a single pointer, to some position in the string, right? We pass that, we're passing that pointer by reference. So we pass the address of that pointer into string to D. String to D then places the value it calculates inside of the memory cell indicated by the passed pointer. So that essentially means that, this comes out of the function still a single pointer, although it's sort of temporarily considered a double pointer for the purposes of passing that pointer by reference. But there. Yeah, because the function requires the address of a pointer, and ampersand gives the address. Yes. All right. I think that's everything for the time being. Cool. All right. Take her easy, folks. I'll be seeing you later.